presentations now. And this year, I'm joined by Miss Kishana Bell. She is the Jamaica Institution of Engineers Student Chapter representative from the Caribbean Maritime University. So she will be assisting this morning. She will do the introduction for engineer Dr. Christopher Burgess. And the first presentation is on Marcus Garvey Drive Drainage Study. So I now hand over to Ms. Bell.
Good morning, everyone. So Mr. Burgess is the Managing Director of CEAC Solutions. He holds a doctorate in climate studies, a master's in environmental engineering, and a bachelor's in civil engineering. Dr. Burgess is a registered professional engineer, a member of JIE, and a past director of the Professional Engineers Registration Board, Spectrum Management Authority, Donald Quarry High School, and the Jamaica Council for Persons with Disabilities. Dr. Burgess has also worked extensively with regional governments, lending agencies, developers, and other consultants in a range of sectors. He is also a real estate developer and has authored and co-authored several papers published in international peer-reviewed journals, including the Journal of Hydrology, Regional Environmental Change, and Natural Hazards. Over his nearly 30 years in engineering, the spectrum of projects he has worked on includes infrastructure, housing, shoreline protection, and environmental remediation. So at this time, I welcome Dr. Burgess.
Thank you, Kishana. Thank you, Gary, President Ricketts, and Minister Charles. Thank you for your greetings earlier. I'd like to share my presentation. Second. Good morning, everyone, again. Small correction to the title of the presentation. I'm going to speak a lot less about a flood control study from last year and more about the economics of Marcus Garvey. The title of the presentation is Every Time It Rains, Marcus Garvey and the Economics of Road and Flood Control Improvements. A little outline, by way of outline, what I hope to do is to provide some sense of the cost of the investments and the economics, a little bit of background on the traffic and the flood control characteristics, the floodplain characteristics, and really the focus of this presentation is the damages and losses and the efficiencies of various interventions which are possible. Just a little bit of background on Marcus Garvey. It was the first legacy project delivered in 2017 by the National Works Agency. It has a long history in the making. For those who know, in the 60s and 50s, the shipping to Jamaica was by virtue of piers. And if you go downtown, you see remnants of some of these piers. In the 60s, 70s, 4 Jamaicans got together, including Mr. Matalon, and decided that, this needed, and Mr. Kennedy from Grace Kennedy, that the shipping into the country needed to be transformed, or the shipping industry. A part of that was landfilling the area which Marcus Garvey now sits on, and the port, which is there. Whilst this was happening, Portmore was developing, and as you could expect, when you develop large tracts of land, traffic starts to generate. I have a short video to play that gives a better overview as to the history of this stretch of land.
The story of how the Portmore Causeway became a toll road. It should be interesting to know that Jamaica's first causeway, initially called First Harbor Causeway was a combination of dredging and infilling. The industrious Mr. Moses Mataran is credited for approaching the authorities with the idea of this causeway. In 1967, an estimated £1,150,000 was invested in the Portmore land development, the same year that the causeway construction went underway. As it progressed, it rose out of the waters of the Kingston Harbor from Newport West in Kingston over to the Port Henderson Strip in St. Catherine. The Jamaican government, along with the Commonwealth Development Corporation, covered the cost of the causeway. A tour of the causeway by Minister Edward Seaga and Sir William Rendell, among others, on January 21, 1970, signaled its opening. However, the bridge was closed for repairs on November 23, 1990, as it was impacted by Hurricane Gilbert. 70% of this repair cost was covered by the road fund, while a new highway running northward towards the Mandela Highway was constructed by the developers of Greater Portmore due to more persons purchasing vehicles, resulting in an increase in traffic. However, this did not alleviate the traffic issue, but later gave way to the one-way system that was put in place in 1995 to ease the tension and delays during peak hours. But that too was short-lived. It was not long after that the government of Jamaica, in an effort to upgrade the country's infrastructure, provide economic opportunities for growth, and create jobs, decided that the Highway 2000 construction was a good idea. The Highway 2000 project was created at a total cost of $1.3 billion, resulting in it being the largest project in Jamaica. Lane Bridge, stretching 6.4 kilometers in length and runs between Kingston and Portmore, serving as an alternate road to the Mandela Highway. Objection to the Portmore leg of Highway 2000 came about due to various oppositions and conflicts of interest, which entailed land sale and the proposed introductory rate of $65 toll fee prior to its opening on July 13, 2006. The story of how the Portmore Causeway.
There we have it. So in the first instance, we have the people of Portmore transiting over this causeway and generating a lot of the traffic which traverses Marcus Garvey. And so in 2006, there was a minor road improvement project. And then it was followed by the legacy project that we know about, not the upgrade that we know about in 2016-17 at the cost of 22 million, approximately 22 million. The objective of this project was to reduce travel time by 30%. The minister at the time, Minister Davies, was quoted, well, the Gleaner quotes him as saying that the project is expected to be a leader in the improvement of drainage infrastructure. It sometimes is unclear to me what exactly being a leader means. Is it that it leads what is to come, or lead in terms of setting an example? Notwithstanding, for the purposes of the presentation, I'm going to go through a few concepts that might help to clarify some ideas that I will use later on. So the first idea I'd like to discuss is that of level of service of roads, A to F. The idea behind widening Marcus Garvey from 4 lanes to 6 lanes is really to improve the level of service. You could imagine that they would reduce it from a level of service F, which is, we call it a forced breakdown, to a level of service C, where you can more or less, not free flow, but free flow in peak. Peak is 8 in the morning going east, and approximately 4 or 5 in the afternoon going west. An important part of level of service for roads dealing with congestion is that there's a cost which is often not taken into account, and that's the traffic losses from the time that you spend in the traffic, as well as if you want to divert from the road. You could imagine now there's less reason to divert from Marcus Garvey other than in a rainy period, primarily because the traffic is free flowing. But before, in 2015, and we'll have to kind of bring our minds back to 2015, You could imagine that you know, it would take you longer to traverse, and the persons who are in their vehicles, their time is worth something, particularly those that are working persons. And obviously with the volume of traffic on the road, that has an associated cost, which is, it's easy to account for. The cost for diverting around a road, it's pretty obvious. You know, it costs you more fuel. You usually end up taking a longer route, although it's a longer route. Another concept that I'd like to discuss with you is that of damages versus losses and direct versus indirect damages. You know, we're speaking about Marcus Garvey not only because of the benefits that it offers in terms of traffic flows, but also because of the obvious need for flood control. And when you're speaking about flood control, you have to kind of weigh in what are the benefits of the project. The benefits of the project are in essence the difference between the damages that you incur without the flood control versus the damages you incur with the flood control, which hopefully will be less. So in the context of damages, it's useful to consider that some damages are direct and they're very obvious. Building gets inundated and the contents are damaged, and as well as obviously mortality. Indirect damages have to do with business disruption, which you'll hear a little bit about later on. And so just in summary, damages are loss of property. Losses are typically the result of that loss or that interruption of using your property. Direct losses are pretty evident, things you can see, whether it is a factory inundated and the goods are lost, or indirect in terms of the disruption to the business. In this regard, in terms of evaluating the economics of the Marcus Garvey traffic and flood control works, it's very useful to look at what is expected of us globally. You know, in this regard, the Asian Development Bank, IDB, the British Treasury, World Meteorological Association, and World Bank, they have many good guidelines as to how to conduct this economic analysis. And so a lot of the damages and the losses that we'll talk about later on and how we rationalize them pulls from materials from these sources. Another set of concepts, that of damages, are annual average damages, and that of benefits. Average annual damage is a concept used frequently in the disaster risk arena and in the climate change arena. You know, someone may say you have a chance of damage in a 10-year return period of say 25 million. What is that worth? But damages are not only particular to a particular return period, but a spectrum of return periods. And so one way we rationalize damages that we have from, for example, a 1 to a 10-year return period, or preferably a 1 to a 100-year return period, is by summing the probabilities, the probabilistic damage of each of those events. And so it helps us to arrive at a number which we call average, well, annual average damage. Sometimes I'll substitute damage for loss. In this instance, it's essentially the same. Another concept which we have to get used to is benefits. As engineers, very often we're called upon to design drains or flood control or shoreline protection works, but it has to be rational. You don't just build work for the sake of building work sake. We're a country with not necessarily scarce resources, but scarce resources. And so we have to look at what are the benefits of the works in a probabilistic way. And so the benefits of infrastructure work really is, what was the loss before you had it and what is the loss or damage after you build it. And that difference is what we call the benefits. It's deferred losses, for want of a better way of putting it. Another concept is that kind of brings some of these things together is economic analysis. Not a framework rather. and economic analysis really rationalizes costs and benefits, and try to rationalize how and why people make decisions about the use of resources and the benefits which flow from it. There are some little limitations to economic analysis that it's focused on efficiencies and benefits. And efficiency, they say, is important in order for society to progress, but it doesn't really take into account who benefits and who incurs the costs, which can be an okay thing in the context of national development. But that's one of the limitations. Another thing about economic analysis is that you try not to, it helps you to rationalize not overspending. So yes, we could build the biggest flood control or the widest highway, but the cost of investment may start to outstrip the benefits that you could incur from that investment. And so what we try to do is to find an optimal point for the investment where you don't go overboard. In rationalizing the results of economic analysis, there are several metrics. As we would have heard about net present value, benefit cost ratio, or internal rate of return, you know, from some of our projects. Net present value is benefits minus costs. And the rule is that you select the project which has the highest net present value. Notice that it's benefits minus costs, the net present benefits minus the net present costs. You have benefit cost ratio, which I find seems to be a default with some technocrats, which is pretty obvious, the ratio of the benefits divided by the cost, and obviously it must be greater than 1 in order for it to be recommended. But this isn't really true in the international arena. It seems as if though in the international arena of lending agency, it's the one with the highest benefit. Yes, but it must have benefit cost ratio greater than 1. Likewise, with internal rate of return, in this case, we're speaking about economic rate of return, not financial rate of return. The NPV of the project must be higher than the social discount rate. Social discount rate essentially is a internal rate of return which you want to exceed in order for it to make sense at a national level. This number varies between 1.5% to 6% for some countries. The most detailed study I've seen in the region is that of St. Kitts, which was 3.5 to 4.5. I haven't seen any specific to Jamaica, but we can discuss that a little later on. But the rule is that for the project to be viable, the internal rate of return must be higher than this social discount rate. Not that it must be the highest, but it must be higher than the social discount rate. So in other words, the economic metric that you use to choose a project is called the net present value, is the net present value. And you choose a project or you recommend the project on the basis that the benefit cost ratio is greater than 1 and the internal rate of return is greater than the social discount rate. Excuse me. All right, we're going to speak a little bit now about our project, physical aspects of our project. Marcus Garvey Drive at present has a traffic volume of about 52,000 based on National Works Agency in both directions. And this has, it seems to me that it has grown from about 40,000 in 2015. So you can see the obvious increase over the few years. It has a mixture of vehicles and based on the statistical data from both Statin, World Bank, and other sources, so we can very easily, based on these characteristics, value, you know, a minute of delay or 10 minutes of delay on the Marcus Garvey Drive. I'm not going to play this video, which shows a more or less level C flow, but as you can see from the picture on the right, there are times that it still does get congested. But notwithstanding that, you can see in terms of travel time, heading east, you know, you can expect about 15 minutes in the morning And heading west, you can expect about 16 minutes in the afternoon. And these are important numbers at present because we can compare them very quickly with what happened in the past. So, sorry, in the past, we'll take you 16 minutes, and now it'll take you about 12. Heading west, in the past, will take you about 16 minutes, maybe even half an hour. Now it'll probably take you about 10, 12 minutes. That has a value economically. We're going to move on a little bit to the socioeconomic characteristics of the area. Now, when I'm speaking about the area, I'm speaking about this red box. This red box has Tinson Pen, Newport West, and in the east, the Shoemaker Gully in this project area. And in this project area, you have a mixture of development types. You have commercial buildings, residential buildings, and we're able in this particular study, I'm speaking a little bit about the flood control study from 2020. We can easily determine from digitizing the number of each of these units. Each of these dots represent either commercial or residential units. And you can kind of put a typical characteristic to them in terms of footprint and value to them. In terms of economics, you have to use some assumptions. So for example, use an assumption that the replacement cost for residential units is about 900 US a square meter, and for commercial building it's about 1,300 per square meter. And this is based on the typical scenario. All right, we're going to speak a little bit about the economic characteristics of Newport West. And I think this is very important in the context of our project area. Newport West is the hub of Jamaica's cargo shipping industry. It's over 80% of the cargo, as you can see. And between three companies down at Newport West, you're speaking about annual revenues in excess of 200 million US dollars. We're talking about Port Authority, Kingston Freeport Terminal, Kingston Wharves, and Highway 2000 Portmore Leg. It's relatively easy to get this information because most of these companies have annual reports from which you can extract information. A little bit about H2K, that the Portmore Leg, which goes predominantly over Marcus Garvey Drive, accounts for almost 50% of the traffic on the highway. It's not 50% of the revenue, it's about 30 to 40% of the revenue of the east-west highway, but it's still a considerable volume in the context of the industry in terms of the highway that goes over Marcus Garvey Drive, valued at about 15 million in revenue, annual revenue. A little bit about the shipping industry. It's the largest global transshipment port in the Caribbean. As I said before, it generates about 200 million US annually. And that doesn't include, and I just want to make this clear, it doesn't include about 80 small players or smaller players that are resident in Newport West. And so you can imagine that this number of 200 million might very well be north of that, 250, maybe 300 million. But these are certainly the larger players in the shipping industry. And you know, if we're to compare it to the increase in our net internal reserve for Jamaica, which increases between 300 and 400 million a year, you can see that the contribution of Newport West is considerable in the context of the Jamaican economy. This is not a surprise. In 2001, Ms. Clark did some research on the productivity of our shipping industry, and she said, due to the terminal not being able to maintain higher productivities, shipping lines such as Maersk Sealand and Evergreen shifted all or most of their moves to other terminals in the region. There's a lot more that she said, but the essence of this statement is that we must not believe that because we're the biggest in the region or that we have national importance that we can't lose key players in this industry or key clients in terms of ships that come our way. We have to maintain productivity, we have to reduce vulnerability and increase resilience so that we become more attractive relative to our regional competitors. All right, getting into a little bit of the engineering now that relates to Marcus Garvey and the flood control. The floodwaters which actually reach Marcus Garvey emanate from as far northeast as Halfway Tree, Crossroads. And the topography is quite interesting. It's relatively steep when you go north of Marcus Garvey, slopes of 1 to 3%, and very flat as the water flows from southeast to northwest towards the intersection of Chesterfield and Marcus Garvey. Less than 1%. We'll see a little bit of that. But a key point to note here is our hydrology or meteorology. When you look at the rainfall associated with this catchment, you see Cavalier, which is an NWC facility, and Halfway Tree. In terms of our 2-year return period, the depth of rainfall you could expect is 98, 10-year, 213. Some of the major flood events that we've experienced down there, for example, September 2019, October 2020, of 79 and 50 millimeters, you can quickly infer that those rainfall events were less than the 2-year return period. And when we do a little bit of number crunching, in some instances, less than the 1-year return period. And that probably explains why it floods, it seems like twice a year, close to now. In the context of the meteorology and the climate and the hydrology. The catchment, the flood control that exists in the area floods in approximately the 1 to 2 year event. In our flood control study, we built several hydraulic models. Kishona, maybe you want to mute your, yes. We built several hydraulic models and we calibrated them against observations from interviews with residents and commercial interests. And what we discovered was that, we're certainly able to simulate what exists or what occurs. And you see on the right-hand side, essentially, the observation of residents versus what we're able to predict. And so we were pretty confident with the hydraulic model that we were able to build. Key takeaway from this is that the commerce in the area has to stop during these flood events when a lot of their businesses are flooded or the access to their businesses and the port is flooded. Commuters have to stop, and obviously communities get flooded. A little bit about the existing drains in the area. Several major drains. One of them is not here, which is the Shoemaker intentionally took off. Oakland Drain, Clifton Drain, Stewart Drain, and the Tinson Pen Drain, which really is half of the cause of the flooding issue down there. The Jew Gully, which goes through Majestic Gardens, and the Hunts Bay Drain, which essentially combines both the Tinson Pen and the Jews Gully. The Tinson Pen actually combines the flow of Oaklands, Clifton, and Stewart. And in this table, you'll see where I have the sizes of the drains and their slopes, their capacities, and the peak flows, and the inundations. And an important hydraulic number, the fluid number, which basically indicates to us the stability, or the change between the fluid number indicates the stability of the flow. And you can see very quickly that Tinson Pen has a very flat slope, 0.15%. And it's actually going from supercritical flows in those steeper part of the catchment to subcritical flow in the flat, shallow part of the catchment parallel to the Tinson Pen aerodrome. And for those of us who did hydraulics, you know, when you go from supercritical to subcritical, you get a hydraulic jump. A similar thing happens in the Jews Gully, but I left off the lower reach, which also is very flat. An important thing also with the Hunts Bay drain, which receives all of this water, is that it is very flat, 0.1%. And there's no real well-defined channel in that area. I'm going to pause here a little bit just to discuss two pictures here on the right-hand side. The first is the Marcus Garvey Tinson Pen culvert. This is a culvert you go over on the way coming back up Hagley Park Road. And you can quickly see there's a car in the picture. The dimension of this culvert is in order of maybe 6 meters by 2 meters, and it's receiving a flow of 170 meters. Very quickly you realize that 170 cubic meters cannot go through this culvert. Yet this culvert was just built. Similarly on Chesterfield Road, on the crossing, you have a crossing which is in the order of 7 meters by 2 meters, receiving 170 cubic meters. You can see 170 cubic meters cannot go through a culvert that is 7.5 by 2 meters. It's obviously going to flood, and the flooding essentially in this area is predictable. And that's a key point here. The flooding of communities, the flooding of commuters, of commerce, it was predictable and it is predictable. It's not a wonder. And for the improvement works, the 10-year return period, we can ask them later on why the 10-year return period. The drain sizes that we propose to limit inundation will solve the problem of inundation. We'll have to live with the instability of the flows, but essentially we need drains that are in the order of 4 to 5 times larger than exists at present. Another interesting feature of Marcus Garvey Drive and the associated flood control, this is next to the coffee factory, coffee warehouse. This drain, as you can see, this culvert, as you can see, is almost at capacity. Rainfall is less than a 2-year return period. It wasn't even raining when we were taking this picture. Some hours afterwards, and it's already at capacity. So this is an next anomaly in the whole flood control works that were just put in. Well, were put in 2017. So now we have an understanding of the catchment, the economics. I want us to have an understanding of losses, because the two of them have to come together. It's not only about works, but it's about the losses associated with commuters, with commerce and communities that helps us to build out the story. So I want us to watch 4 short videos.
In the meantime, we revisited some areas in the Purple area where there was major flooding on Sunday for the entire town staff.
Our first stop was Marcus Garvey Drive. This was a road on Sunday when TVJ News visited the area.
Tinson Pen Aerodrome, Tara Courier Service, and Kingston's Wharves Auto Cargo were places mostly affected by the flooding. We spoke with some employees from Tinson Pen Aerodrome who gave an account of what happened on Sunday. The entire car park over there, it was flooded. Both entrances, we have 2 entrances to access the aerodrome. Both entrances were flooded. No one could come out or come in. Right? We had an officer yesterday. He was trying to get out to go home and he couldn't. So everyone there, we were trapped. Luckily, the water receded quickly and they could go home. But the debris behind me stands as an obvious indicator of the aftermath of flooding as a result of Tropical Storm Elsa. On Sunday, this entire area outside of Tinson Pen Aerodrome area was flooded, stalled some vehicles, but today we can see that traffic is free-flowing and things are back to normal.
We also spoke with the CEO of Kingston Wharves Limited, Mark Williams, about plans for the vehicles that were submerged in water at its global auto logistics center.
But for us, we have in excess of 3,000 cars over there, and a small percentage, less than 5%, was affected. What we're doing at this time is we're doing complete car detailing of those cars, and they should be up and ready for distribution shortly.
In the meantime, we visited some areas in the public area. Sections of the public areas were again flooded after heavy rains associated with an area of unstable weather linked to Hurricane Delta. Poor drainage is being blamed for the flooding being experienced on Marcus Garvey Drive. Videos received by a news team showed persons pushing their vehicles in almost waist-high water along the 6-lane road. That issue has been a long-standing one. In 2016, flood waters from that road destroyed approximately $1 billion worth of coffee beans, which were being stored at the Wallingford Coffee Company warehouses. In August, the National Works Agency, NWA, said it could cost up to $1 billion to build a drain that is adequate to prevent flooding on Marcus Garvey Drive. Executive Director of the NWA, E.G. Hunter, made the disclosure during a Jamaican Post press briefing. Mr. Hunter said the road that was reopened in 2017 after a $20 million upgrade work does not have adequate drains.
Right, and so we can see from these two videos and imagine the disruption to business, the damage to property and vehicles. And I should have let this video play a little bit more. The gentleman from Kingston Walls, Mark, he does recognize that this is a wider problem. This is not a problem which emanates from the road, which would be drainage. This is a problem which emanates, as I showed you earlier, from further upstream. It's a larger problem. I have a difficulty with this estimation of his losses, but it's his losses or his shareholders' losses. And so he said 10% or 4% of his vehicles were damaged. Let's hope the detailing solves the problem and it doesn't end up in our hands. But let's move on. Sorry. All right. And so what we saw a while ago was the damage to commuters and commerce. And I think it's important to get now to the communities. I'm going to show you two videos. One is not from this project area, as I've noted here, but both of them get across the point in terms of what people lose when their homes and their communities are flooded. Sorry.
Yes, Rosie and her family were sleeping, waking up, feel water and waking up, right through the house, through the bathroom, through every door, kitchen door, every door. Everything in the house flood out. When we talk about everything. The bed now they sleep on, settee, where you could have rest in a phone, where you could have made phone call and video for sure. Everything flood out and warm up every single piece of sleep.
You were sleeping on?
We were sleeping.
Yeah, and
we were sleeping, hear Prince screaming. When Prince screaming to water, when you jump up and look, there is water. Many water, like Elsha. That type of water was here. And we warm up everything.
Right.
It was time to rainfall, we flooded. Everyone flooded.
Residents of Majesty Gardens say they have been suffering for far too long whenever it rains. They say their houses are now at risk with the recent torrential rains.
Everyone flooded. Nobody can stay at them place. I'll be a family and friends place, they have to stay for the place stay. Like twice myself, I can't stay at my house, at my girlfriend's place. I don't want to stay out on the kingdom with me.
And to make matters worse, a broken down section of a nearby gully that overflows and transforms the community into a swamp.
We need the council and somebody to come do something about it to the community. We don't have to suffer too long. You see me? All right, you know, I be a promises rabbit and that can't help.
Member of Parliament of the Southwest St. Andrew constituency, Dr. Angela Brownberg, says the gully will be fixed in short order. In addition,
the truth though is that for individuals living in this particular area, which is prone to flooding for a number of years, I think that the more permanent fix would be to ensure that we have a kind of housing down here that lifts the houses from off the ground, that allows water to flow, and to also see how we can stop some of the water from flooding over the gully. It's a major issue. It's not something that comes of the Member of Parliament or even the councillor who would have responsibility for the gully.
Right. And so from the two videos, you can quickly get a feel for the value of what they have lost, what it means to them. Health-related issues, Rosie spoke about her baby and the water. The gentleman in Majestic Gardens you know, he hints at the loss of community connectiveness and cohesiveness. Everybody is dislocated whenever they have to move out and move around. And just a little note here, you can see that Dr. Burke is speaking about lifting the homes, etc., etc. And later on in the video, they speak about, well, you can imagine, and you'll figure out later on that with $20 million that a member of parliament gets, she'd have to save all of that money for 93 years to tackle the problems associated with just her, well, the drain that runs through her constituency. So again, this is not a local problem, this is a larger problem.
Yes,
right, and so we're going into the economic analysis very quickly now. We're speaking about the efficiencies, the capital cost, capex versus the benefits. And you can see on the left-hand side, the benefits of the road, reducing the transit time along the highway. And you can see on the right axis, the benefits in minutes, the costs, the time saving. And when we value this time saving across 24 hours of the day and across a year, which varies between 2 to 6 minutes, moving the road from a level of service F, which it was in 2015, to approximately C in 2016. That benefit from the road and drive period is worth about $11.1 million US annually. Similarly, we can look at the losses to residents and commerce and commuters in the project area, and we can value their losses, and their losses are valued at about 18 million. And if you put in flood control works, we can reduce it to the 10-year return period to somewhere around 9 million. Unfortunately, with the traffic losses that are still being experienced in the wet period, we estimate that the traffic losses are worth about 3.5 million. That has to do with, for example, Mark from Kingston Wolves and his cars, the persons who get stuck, their diversion costs, the person like the gentleman whose car he had to be pushing. And so that too has a cost, especially if it happens twice a year. Maybe if it happens, you know, once every 5 years, it might be tolerable. And we have other costs to consider, not only the capital cost of the road improvements in 2015 of 23 million, but also capital costs of the flood control works of about 56 million. And unfortunately, because of how the works were carried out, some of those culverts which we spoke about earlier will also have to be replaced. And that's going to cost about 3.9 million, because not only do you have to dig up what is there and to replace it with something, but whilst you're doing that in the context of Jamaica, you're speaking about at least 3 months of construction time, as one engineer said, possibly 4, unless the Chinese do it, but that's another story. And so I'm going to go into economic analysis very quickly. The first thing in economic analysis is to value what we call the status quo. The status quo in this case, I'm going to carry back to 2015, 2017, where we value the losses that we spoke about from traffic delays, the losses due to traffic delays in wet periods and flood damages. And we can quickly see that the road improvement, which removes these traffic losses due to delays, before the road improvement works, we're looking at annualized losses along Marcus Garvey of about 32.6 million. And so 32.6 million is the traffic losses in dry period, traffic losses in wet period, and the flood damages to commerce and commuters and communities. And so this is a starting point for our analysis. And then now we can start going into the efficiencies to first of all determine preference. You know, what's the preferred project to implement? And so we can contemplate 3 projects in this instance. One where we upgrade just the road alone, which is what was implemented. What if that implemented the flood control first in 2017? Or one where they implemented both the road upgrade and the flood control in 2017. You have to remember the metrics and the rules that we spoke about initially, that you look at the project with the greatest net present value of benefit. on the basis that it must have a benefit cost ratio greater than 1 and an internal rate of return greater than the social discount rate. Let's use 4 to 4.5%. And you can see all of the alternatives pass the initial hurdle of benefit cost ratio and internal rate of return. And so just to sum it up, all alternatives are economically viable. And this makes decision-making, it can make decision-making more challenging. And I can appreciate that. But it also suggests when you look at the analysis that implementing both the road and the flood control works would have had the greatest benefits. You can see the MPV of the flood control and road works at 276 million. However, we understand that as a developing country, as I said here, in an environment of scarce resources, the implementation of the road work, it is the cheapest alternative. It was the low-hanging fruit, and it has positive MPV. So in the context of commuters in dry periods, this is a reasonable choice when you have scarce resources to deal with. But in the choice, in terms of an economic decision, the best choice would have been, if you had the funds, would have been implementing both the road and the flood control works. We can look at sequencing, which is another important factor to consider. We have the road upgrade works, and we can contemplate 3 scenarios: the road upgrade and the flood control works in 2017, the road upgrade and culverts in 2017, which was not done, and then the flood control works in, say, 2025. Let me make it clear here that putting out 2025 here is an estimate, and this is not a stated commitment of government or anything like that. I haven't heard this through the grapevine or anything, but for the purposes of this presentation, I use it as a benchmark. And then there's a scenario that we kind of are forced into, which is where we'll have the road upgrade, and then it's followed now with culverts and flood control in 2025. And we have different capital costs associated with those scenarios. We have the added costs of taking out the culverts that we're putting that are not very useful in comparison to if they were put in before in 2017. And again, you can see, obviously, doing the road work and the flood control works in 2017 would have been the preferred alternative, preferred approach, but in an environment of scarce resources, implementing both the road improvements and the culverts in 2017 would have been more beneficial to avoid the cost of the culvert. You can see the difference between these 2 scenarios, 219 million versus 214 million. The reason why we're going to lose a benefit of about $5 million in the future when we implement this is because we have culverts in the works that are not relevant to the long-term picture. But notwithstanding, this is what we're stuck with. This is the scenario we'll have to go with. What about doing nothing else? What if we do nothing else? And very quickly, you can see from the MPV that it suits us to do the flood control work to limit the damages which we are currently experiencing. You'll see the average annual damage or loss here of 21 million in the current scenario versus 10 million if we put in the flood control works designed to a 10-year return period, and 5 million if we design it to a 50-year return period. Again, this annualized damage is really the costs that the commuters, the commerce, and the communities in the area are paying. Let's not fool ourselves that the commuters are not paying the price for this. The majority of it is obviously borne by the commerce in the area and the communities in the area. And the preferred sequence is obviously following what we've done now to design and install a 50-year return period. It has the highest NPV of the 3 alternatives. And also of the 3 alternatives. Let me go on to, and I must draw your attention to the fact that so far in all of this analysis, I've done it to the present climate intentionally. I know, what about climate change? Well, in climate change, in a reasonable climate change scenario, we expect that the rainfall intensities are going to increase somewhere between 6 and 12% across the project area. And so obviously, if the rainfall intensities are going to increase, then the damages associated with rainfall intensities are likely to increase. And so when we look at the future climate, again, we see that the scenario which contemplates the 50-year return period in a future climate is the more beneficial project, has the greatest benefits of all. So I go on to say here, flood control works to the 50-year return period is the most efficient scenario, the higher NPV and a higher rate of return as well than the do nothing else scenario. You can see an internal rate of return here of 48% versus 51%. May not seem considerably different, but this is the preferred scenario to upgrade the road, to upgrade the flood control works to the 50-year return period. Some other considerations, Tinson Pen. Tinson Pen is approximately 90 acres of aerodrome, which is a loss-making venture. This is an excerpt from the Airport Authority's annual report. And the 3 aerodromes are basically loss-making. And so I'm putting a suggestion here, not only to develop the land, but to develop and sell the land to light industries. I know that there are thoughts of extending the port over on that side. But let's say it was diverted to light industries, the government could realize approximately $200 million once the flood control works are installed for this parcel of land, and to stem this loss from the aerodrome. There's a great shortage of flex space and warehouse space in Kingston and St. Andrew, to a lesser extent St. Catherine, but it's not possible to develop this land into warehouse and flex space with the flood control issues which emanate from it. And very quickly, we've been speaking about economics for the last few minutes. There are other ways of making decisions. One of them is the multi-criteria analysis method. And when you attach weights and the inputs of various stakeholders to, for example, the traffic delays, importance of traffic delays, the importance of flood damage to commerce, as well as a national perception of flooding a little bit higher than other factors, and you look at the scenarios which are examined earlier, you quickly realize that it's generally a good idea to upgrade the flood control works. It would rank #1 in terms of a project. And just to conclude, Marcus Garvey floods, because Marcus Garvey dry floods because of unstable hydraulic conditions and crossings and channels that are undersized. What is needed is in the order of 4 to 10 times larger. The annualized damage in 2015 is estimated at about 32 million. With the highway, with the motorway in place, that has obviously been reduced to about 21.5 million. Nonetheless, the commerce and the communities in the area, are still suffering from flooding. And as we see from the economic analysis, in putting in place the flood control works alongside the road works would have been a preferred approach. It is nonetheless understandable that with scarce resources that you have to choose what you can afford. And just to wrap up here, that economic analysis, when you consider climate change and when you consider the developmental potential of Tinson Pen, it would suit us to complete or to start and complete the flood control works. There are great benefits to be realized from the Tinson Pen area and from just solving the needs of the commuters and commerce in the area. And as a final general recommendation, when I look at the issues involved, I think there is a need for us, Minister Charles kind of alluded to building better. For us to follow government policies faithfully. And when I say faithfully, you know, this highway, this motorway should have had the benefit of an environmental permit under the NRC Act of 2000, NRC Act, and the Regulation 3 in 2015 speaks to motorways of this size. And maybe if it had an environmental permit, you know, some of the shortcomings would have been caught. Also, if the Minister of Transport and Works had, you know, probably followed the hydraulic guidelines a little bit closer, would have had culverts maybe with capacities up to the 100-year return period rather than the 1-year return period, and you know the flooding would have been mitigated. And lastly, in terms of the climate change policy framework, of which the National Works Agency was a member in the formulation of the policy. There are two key principles. Principle 2, a multi-sectoral approach to climate change. Government will mainstream climate change adaptation considerations in projects of all ministry departments and agencies of the government. And principle 4, the precautionary approach. Government will apply the necessary strategies and measures to ensure an effective response to the impact of climate change. If we follow these policies closely, we can mitigate some of these losses. Finally, I'd like to acknowledge Andrew Foreman for his input, and the Airport Authority for some of the data we use, the Works Agency for the opportunity to do the flood control study in 2020, as well as the staff and associates of CEAC who greatly assisted us. And that's the end of my presentation, Gary. I have a short bit of music to play as we wrap up. Just to note that we're dedicating this presentation, Mr. President, to Rosie from Bacto, Mark from Kingston Walls, and Flood from Shoemaker Gully. This is Flood out here in the picture on the right hand side. His colleagues, his community residents gave him that name because unfortunately he seems to suffer the brunt of it whenever it rains down here. I will hope that this presentation was useful, you know, and helped to shed some light on the, you know, the way forward, and hopefully we can get it right going forward. Thank you. Yes, Gary, over to you.
All right, thank you, Engineer Burgess, and Flood Out. I'm back to. Their sacrifice to be a part of your study is noted.
Gary, that Chris's presentation ended like a Stone Love sound clash.
All right.
You notice that the lady Rosie noted that the flood water came like Hellshire, and I only put that in there because of you, Jamel, because I know you're going to speak about Hellshire next.
That's the same 30 grand Rosie?
30 grand Rosie.
With our TV, so. With our TV.
Yes, it's possible. It's possible.
Okay.
As I noted, though, you know, it was from a different catchment, but the story and the lessons remain the same, you know?
Mm-hmm.
Yeah.
All right, fellow engineers, ladies and gentlemen, you know that maybe some of you are struggling with Zoom, but there's a question and answer window. And when I go in there, it's closed. It's nothing. And they're not supposed to use the chat, they're supposed to use question and answer. I'm introducing them to the new Zoom because the chat has so many things. Anyway, Melissa will try and go through the chat and bring up the questions, but I have one for Engineer Burgess. Two. I was surprised when you said that the drain in the vicinity of Hagley Park Road transition into Marcus Garvey Drive, that culvert rather, it was built recently, and notwithstanding that it was built recently, that it was undersized at that point, having learned all the lessons from Marcus Garvey Drive. And the next one is there was, you mentioned Jules Gully, Shoemaker Gully, and another one that he said he didn't want to mention. You didn't want to mention that one because it was insignificant, or it was?
Oh, it didn't add to the story. It was Lower Jew Gully.
Oh.
No, actually, where the gentleman floods in one of that video, where the one with Dr. Burke, that's where he floods. Lower Jew Gully. But it wouldn't add to the story. I think the story here really is that transition from Oakland, Clifton, and Stewart to Tinson Pen, where you have this hydraulic jump and there are no drains. And it's the same thing which happens around Jews Gully, flood the communities. This is all predictable. This can all be worked out on the back of an envelope. And yeah, so it didn't add to the story. It's not for any other sinister reason or any sinister reason.
So your flood control study, you certainly, because from what I gather, these drains start way up into Upper St. Andrew, correct? Collecting water from as far as Hope Road coming down?
Yes. Yes.
So I suspect your flood control would have recommendation for what? Additional drains or improvements to the existing ones?
Improvement to the existing ones that come down towards Tinson Pen. But the majority of the work really is Tinson Pen, Jews Gully, and Shoemaker Gully, very close to the Marcus Garvey and parallel to the Marcus Garvey. There's another major piece of work which goes from Chesterfield and Tinson Pen and to Huntsby. So, you know, as I was telling Andrew Foreman, some of those canals in Greater Portmore, when we're finished with the calculations, the canal that is required from Chesterfield to Huntsby looks very much like what you have in Portmore in terms of dimensions and size. And so, you know, as I tell you, you know, we don't really hear about Portmore flooding as badly as other places. You know, the engineers there certainly knew the solution in the 60s and 70s when they were building, and that's just what is needed here. And that's a part of the $56 million that you see is required. It's a lot of work which is unfortunately not visible, or won't be visible.
All right, thank you, Engineer Burgess. Melissa will now pose the questions to you. She's been monitoring them in the chat room.
Yes, morning, everyone. Morning, everyone. Yes, there are a few questions here. Of course, everyone is saying good presentation, Dr. Burgess. First question for you, does the flood control plan require raising the elevation of any of the lands or roads in the vicinity of the problem area?
No, the primary approach is to actually deepen and widen the drains, not to raise the lands. There are some lands like Tinson Pen which will need to be raised, but the approach is really wider and deeper drains. That's what we derived.
Great, thanks. I guess another comment. Well done, Engineer Burgess. Just that the government just need to implement the corrective action soon. So hopefully that will happen soon. Do you know when that will happen?
No, not at all. You have to direct that to the Works Agency. I tried to get them to be a part of this, but unfortunately they seem distracted at this time.
Okay. Another question for you. There was a proposal to do a regional drainage study for the island. How advanced is this proposal, and is this study a part of the regional study? If you are able to answer that question.
Yes, well, we were actually a part of that study, and that study actually ends where this one starts, so to speak. But I don't know about the government's plans to roll it out or their timelines for it. But certainly it was a great study. very extensive study, 21 catchments, I believe, or 21 townships across the island. And that's the kind of work that we need to get done to, you know, get flooding of communities and commerce off of the news.
Okay, thank you for that, Dr. Burgess. Another question for you. In terms of mitigation, what role would maintenance play in reducing the effects of flooding until the recommended improvements are implemented? Also, what the person is saying, I suppose if you upgrade the drains and don't maintain it, we will end up with the same effects. Any comments on that?
So that's two scenarios. So the first scenario of maintenance of what is there. You know, I intentionally showed a picture of those 3 culverts. What is there in terms of the drains as well as the culverts are woefully inadequate. And so it's, you know, it's good optics to have an excavator digging out a drain. You know, there's several pictures with persons standing up near to a excavator. It's not very useful. It's not that you shouldn't do it, but it would probably be better that when you're going to clean the drain to make a concerted effort, okay, rather than just taking out a foot of dirt, I'm going to take out 3 feet of dirt and I'm going to widen it by 6 feet every time I need to clear it. And so maybe eventually after 2, 3, 4 years of maintenance, we would have a drain that we need, or a drain that can cope with the flows that are there. In terms of the second scenario, in terms of maintenance of the flood control that is necessary in the economic analysis of in the flood control study, we actually did consider that. We sat with the works agency engineers and figured out what kind of maintenance might be required and put that in the cash flows, and it made sense to still do the flood control works. And so maintenance is important, and it has to be a part of the budget. And they do, the works agency, but give them benefit. They have quite a bit of maintenance activity island-wide on drains, because, you know, they were able to refer me to 2, 3 huge recent projects that they had and the numbers involved. So when this gets done, it will have to be a part of it in order to make sure that the gentleman in Majestic Garden doesn't get flooded.
Just a question here, Melissa. Chris, what impact, if we correct that bridge that flows from Agley Park Road by the train line, what impact would that have at this time? I mean, a cost-benefit analysis, because if we address that problem right now, how beneficial will that be?
There are some benefits of changing, for example, just that crossing. We actually did explore that in the flood control study, but it's not going to get us to where we need to go in terms of moving the needle on damages. So the annualized damage of 20-odd million, you know, I don't want to grab a number here, it might be reduced to, for example, 18 or 18.5 million. We need to move that number down to 9 and 5 million a year to make it tolerable for the commerce and the communities around. We actually did investigate that, and we actually did investigate the no maintenance scenario in the flood control study and showed where it made sense to maintain these things so that you get the function out of them. I hope that answers your question.
Yes, I just wanted to know, you know, if we can handle some of these low, I know the country doesn't have the resources, but if we can mitigate some of these low-hanging issues, you know, what impact will it have?
It would make a
retention
impact,
pond,
obviously, with the smaller flood events, so like the 1 year,
yes,
2 year event, than it would with the 5 and the 20-year event. But I don't know if you picked up that one of the reasons why Marcus Garvey floods is because of a hydraulic jump and the undersized drain. So the drain precedes the culvert. So fixing the culvert downstream is downstream. The problem is occurring even before, if you get what I mean. But obviously the water would recede a lot faster if you had a bigger culvert for it to go through, or rather the culvert that is supposed to be there. You get what I'm saying? So you may still suffer the flood, but for a lot shorter time, rather than for 3-4 hours, it may be, for example, for half an hour or whatever it is.
All right, this is probably required further studies, you know. But yes, thanks, Chris.
Yeah.
All right, thank you, Dr. Burgess. I think we have time just for 3 more questions. The next one is, in your opinion, would it be possible to have retention ponds in specific points in the city to aid the storm flows similar to South Florida and assist with drainage that eventually ends up at Marcus Garvey Drive?
Absolutely not. We're a city, we're a dense city. You know, we don't have the luxuries of the Everglades and that wide span of land which Florida has. And I think part of the reason, part of how Florida develops is to excavate to get those basins, and then they build on this fill. But we don't have that luxury here. And I want to be very honest and use this opportunity to say that the regulators need to stop this approach of wanting retention ponds in urban areas. Suburban areas, somewhat understandable, you know, like in for example, some communities in St. Catherine, where there is the benefit of a lot of land or land. But in these townhouse complexes or these complexes to ask for retention, you know, ponds, or even in some of the smaller subdivisions to ask for these retention ponds, is nonsense. If you actually look at the benefit of it, it has no physical benefit to the hydrology. So short answer, no.
All right, thank you, Christopher. We have 2 more. One from David Rose. Is there any work around the recent drains? Example, drain under Hagley to Garvey, such that they would not have to be replaced. This as it would come to serious discomfort to commerce and traffic. I'll answer that. They did do drainage work on Hagley Park Road. Unfortunately, if you recall, in the lane heading north to Maxfield Avenue, there was an issue there where the road, it kind of get ripped up, because there was they were trying to use one of the older drains, and there seemed to have been some in a sense the contractors did block it up, so it had to be cleared out and a new one installed. But there was an effort, I guess, for budgetary reasons, to see how much of the old drains you could continue to utilize, but new drains were installed at particular locations. And finally for you, Chris, this is from Ivan Foreman. Given the limitations of government spending, if the flood control work is to be phased, what are your thoughts on the sequence of implementation?
The flood control. Okay, so I think what Andrew is getting at is you have Shoemaker to the east, Tinson, Penn, and Jews Gully in the northwest, and then Newport West to the south. You can see it on this picture here. Certainly, I would prioritize Tinson, Penn, and Jews Gully. You know, let's try and remember, there's a video that I didn't allow to play to the very end. Shoemaker Gully flooding resulted in the loss of several millions of US dollars worth of coffee at that intersection with the gully. So, but notwithstanding that, I would do Jews Gully, Tinson, Penn, followed by Newport West, then Shoemaker. It's a little tempting to put Newport West first because the problem is smaller and easier to solve. But I know that there are certain conveyancing and ownership issues in there where what I overheard was that the roads are still private and weren't turned over from the 60s, and so government is not going to go in there. So that would take some time to unravel. And so whilst that is being unraveled, we deal with the problem that affects the communities and the commuters the greatest, which is Jews and Tinson Penn. I don't know if that answers Andrew's question.
Yes, it does, Christopher. And thank you. Thank you for answering the question. Thank you for your presentation. Liz Walters in the chat but the chat is for the question and answer section is for questions, not big up to tell Chris he did a good job. I'll do that part.
All right, Gary, thank you.
All right, thank you.
Loxon, a name that's trusted for premium performance. Now the Loxon family has a new member. That's Loxon self-cleaning acrylic coating. Engineered for exterior above-grade masonry substrates that require a clean, attractive look, this revolutionary coating provides high-performance protection with enhanced water shedding and dirt pickup resistant properties. It's no secret that over time, ordinary coatings become soiled or stained, either requiring extensive cleaning or costly repaints. But Loxon self-cleaning acrylic coating is formulated to be self-cleaning by shedding dirt upon rain or water contact, extending the life cycle of the coating and saving commercial property owners and managers thousands of dollars in maintenance costs.
Well, there's a lot of things I like about the Loxon product in terms of it's easy to apply. I put it on a textured wall here and it really went on evenly, consistently, and a big part of my job is pressure washing, and any product that can lower the amount of maintenance on a facility like this certainly saves time and money to the owner.
Like the other coatings in the Loxon line, Loxon self-cleaning acrylic coating has excellent weathering properties and UV resistance, and it's mildew resistant too, which means agents in the coating inhibit the growth of mildew on the surface of the coating. The breathable paint film minimizes the potential for blistering and has the flexibility to adapt to weather fluctuations. Loxon self-cleaning acrylic coating is suitable for application over properly prepared bare or previously coated concrete, masonry, or cement board surfaces. Color options are extensive in a flat sheen, and it has fewer than 50 grams per liter VOCs. The power of Loxon's proven performance, combined with the benefit of its self-cleaning formula, provides a great solution to offer your commercial property customers.
The electric motors are used in almost all industries. To avoid loss of production and profit, we need to have the right equipment for maintenance programs. Measurements of inductance, impedance, phase angles, or capacitance are not enough and do not represent the actual state of the art, according with IEEE and NIST organizations. The best practices for maintenance recommend the step voltage test and the surge test. Both tests are done applying high voltages. The tester will stop the test at the moment it identifies weak insulation. The step voltage test can identify weak insulation to the ground, while the surge test weak insulation between turn to turn in the windings. At Megger Baker Instruments, we offer the best motor analyzer for motor maintenance programs according with actual international standards.
Since its construction, Port St. Charles continues to be a beacon for coastal projects in the Caribbean. Encompassing land development, shoreline preservation, ecosystem conservation, and disaster risk reduction, it includes many of the project aspects that Smith Warner has continued to work on over the years. We are proud to have been a part of the team that brought this marina development to life. Building on those same beginnings, we prioritize quality and the use of innovative approaches to solving coastal and marine problems throughout the Caribbean, while incorporating suitable responses to climate change issues. Our people are our strength, and we care because this is our home.
Engr is the world's leader in electrical test solutions. We are dedicated to creating safe, reliable, easy-to-use portable test equipment and to providing expert support locally.
Our customers use our products to make informed decisions about their most important assets. They can trust our products to give accurate results and are tough enough to work in the most demanding environments around the world.
Megr has been around for over a century, pioneering the world's first insulation tester back in 1903. Since then, we have developed worldwide with manufacturing facilities in Sweden, Germany, UK and the USA.
Megr is concentrated on simplifying the task of protection relaying with our reliable and robust test sets. Our flexible solutions speed up the testing process and thus reduce cost and downtime.
Megr offers the broadest range of transformer testing equipment in the industry. This allows a complete transparency of the health of the transformer, helping engineers to manage the life cycle of their most valuable assets.
Megr, and formerly CEAC KMT, has developed a high level of expertise in cable diagnostics and fault location. Electrical utilities look to us to help manage the conditions of their cables using an array of technologies to identify even the hardest faults to find.
Insulation testing of low voltage systems is where our company was founded. We pride ourselves in developing safe, reliable test solutions, but at a low lifetime cost and high performance.
The growing diversity of energy sources has increased the need for versatile testing systems. Megr offers a complete range of general electrical test equipment, including 5, 10, and 15 kV insulation testers, low resistance ohm meters, battery testers, power quality equipment, and many more. What all these products do is focus on productivity, safety, and a dependable performance wherever you need.
Megr engineers share their expertise enthusiastically through regular training programs to customers and distributors. We also have local support teams available to help our customers with their day-to-day inquiries.
The goal is to provide the highest level of customer service, irrespective of location, language or channel.
Through working closely with electrical utilities, standards bodies and technical institutions, we strive to be at the forefront of the electrical test industry.
We value our relationship with our distributor network. In partnership with them, we provide the highest levels of technical service and easy access to applications engineers.
To ensure that we deliver real benefit to our customers, we continually invest into our people and into new technology.
We are extremely proud of our employees who are not only incredibly talented, but passionate about the needs of our customers.
The daily lives of our customers are demanding, complex, and often highly dangerous. We help make their lives safer, and that bit easier by continuing to offer our support, our expertise, and our world-leading products.